Math Genie.
In this video, I'll be explaining how to find positive divisors using prime factorization. If you watched my previous video, you should already be familiar with the concept of prime factorization, how to prime factorize a number. However, if you don't remember, or if you need some recap, because of course it's been a while since I posted that video, I'll link down the video in the description box below, so you can always go check out that previous video before proceeding with this one. But if you do remember, or if you're familiar with this concept, then you can of course stick with me until the end of this video to see how to solve this example question that I have down below. So before I solve that example question, I want you guys to look at the words in the blue box there. So this is a very important theorem that you do have to know. It's a must know for any math competitions because this concept can pop up literally anywhere. So, and that's why I of course put that little star there as well, because this is so important. So a lot of you should actually already be familiar with this, I would say, the theorem, or if you aren't, you will learn this at school as well. But I'll go ahead and just read out the theorem so that you guys can see what it is. If n is a positive integer with prime factorization and n equals this equation, you really don't need to memorize that, then a number of factors is n sub 1 plus 1, n sub 2 plus 1, n sub 3 plus 1, all the way until n sub k plus 1. If you're first seeing this theorem, you should really be saying, what does that mean? It looks too complicated, but I promise you it isn't. So before I proceed with the actual example question, I'll just give you a quick example to basically tell you how this theorem works. So for example, I'm always using this number 24 because it's such a easy number to give an example with. So if we have 24, for instance, and they're asking you how many positive factors, or what's the number of factors that this number here, 24, have? Well, I mean, 24 is a very small number, so you can actually, just think on top of your head, like we have 1, 3, 4, 6. I guess you could list all of them out, but we're talking about some larger numbers in the actual example. So I'll just use this theorem to solve that question. So for 24, again, what you have to do first is you have to prime factorize. You have to do prime factorization first. So I'm going to prime factorize the number 24. So I'll be using the ladder method, which is the method that I always suggest the most. And we know we have 3 that can go into 24. And then we know that immediately 2 to the third power 1, because you know that 2 to the third power is 8. So the prime factorized form of 24 is 2 to the third power times 3, right? Again, remember that the prime factorized form of a number must always be only made up of prime numbers. And we know that 2 and 3 is a prime number. All right, so to find the number of factors, again, that number 24 have, according to that theorem, what we're supposed to do is we're supposed to take this number here, 3, and remember there's an invisible 1 here, so I'll just write that out, and 1. And what we're supposed to do is we're supposed to get this number here, n sub 1, and then we're supposed to plug it in here and add 1 to it. So basically we're supposed to do 3 plus 1, and the same thing with 3 to the first power, we're supposed to do 1 plus 1. 3 plus 1 equals 4, 1 plus 1 equals 2, 4 times 2 equals 8. So without even having to, list out all the numbers, list out all the factors of 24, we can immediately find how many there are in total, right? And we can check this by, since 24 is a small number, we know that there's 1, 3, 4, 6, 8, 2, 12, and 24. That's 8 already, right? So we can immediately go ahead and check that, hey, there is 8 factors, right? 24 has 8 factors. And we just figured that out by just, simply doing prime factorization and by using the theorem that we just learned in the blue box, okay? So this is basically what this theorem is saying. It's a very, very useful theorem, especially for larger numbers where you can't really count all the number of factors there are. So that's why I gave you an example, of course, with a large number. So we'll go ahead and look at that example. So I'll first do the part that says use the theorem, because that's the main focus of this video. So let's use the theorem to find out how many factors 12,600 has. Okay? So what are we supposed to do first? We're supposed to prime factorize. So I'll put down 12,600 right here. And I'll be using, again, the ladder method to solve or find the prime factorized form of this number. Alright, so before we actually do this prime factorization of 12,600, this is just my tip, is to, if you have any numbers that have, again, zeros like this, I like to eliminate them first. So without just starting off with 12,600, I like to get rid of the zeros and just do this. Because, we know that 126 plus times 100 gives you 12,600, and we know the prime factorized form of 100 is 2 to the second power times 5 to the second power. And this is another one of those things, numbers that you must have on top of your head, or else you'll be wasting a lot of your time. So I'm just going to be using this method. So I'll just go ahead and just prime factorize 126, not 12,600, right? So 126, well, I can immediately see that number 7 actually goes in here. 1, 18. 3 can go in here. We can have 6, 3, and then 2. And we'll just combine all of this. So we know the prime factorized form of 12,600 is, how many 2's are there? 3. 2 to the third power times, there are 2 3's, 2 5's, and 7. So we know that this is equal to 12,600. Okay? And let's use the theorem again, this part of the theorem, to find out how many positive factors this number has. What are we supposed to do? We're simply just supposed to take the powers here and add 1 to it. Same thing here for 2. We have another 2 for 5. And then finally, remember that there's an imaginary 1. Don't put 0, because that's going to be wrong. There's an imaginary 1 there, so it'll be 1 plus 1. 3 plus 1 gives you 4 times 3 times 3 times 2. And this will be 4 times 3, 12. 12 times 6, 72. So we know that this number, 12,600, has total of 72 factors. Okay? And this is very, very useful, again, because I'm not saying this question is actually on a competition, because this is a very easy, basic question. However, you can actually encounter problems a little bit more complex compared to this question, but it'll basically be using the same concept. And in my future videos on this prime factorization sequel, I guess, I'll be talking about how to solve more complex problems that basically uses this basic concept. So you can always refer back to, again, this video, because this will be covering the basic theorem that you need to know. Now, as you can see, we actually solved the question, 72. But just to check, I have created a chart that you can fill out. So actually, before proceeding with this video, I want you guys to pause the video and see if you guys can fill out this chart. And before you guys start filling it out, I'll just give you guys some basic things that you must know when filling out this chart. We're just trying to check, okay? We're just trying to check if we did it right. And you won't be doing this step when you're in a competition, because you obviously don't have the time to check over your work like this. However, when you're just, preparing and studying, I do highly recommend you to make a chart, see if you actually got it right. So how you can actually fill out this chart is by taking these numbers. So we know that 2 to the third power, I'm just going to write it here. So I'm going to write 2 to the third power, 5 to the second power. Actually, 3 should come first. 3 to the second power, 5 to the second power, 7 to the first power. I want you to list out all the factors of these numbers. So 2 to the third power, 3 to the second power, 5 to the second power, 7 to the first power. I want you guys to list out all the factors of these 4 numbers here in prime factorized form. And if you're done, and when you're done, I want you guys to resume the video and continue. Alright, so let's see if you guys actually got it right. So there are a total of 4 factors for 2 to the third power, and that is obviously 2 to the 0 power, 2 to the first power, 2 to the second power, and 2 to the third power. Same thing with 3 to the 0 power. 3 to the second power. We have 0, 1, and 2. Similarly, we have the same for 5. And for 7, we only have 2 blanks, which is 0 and 7 to the 1 first power. So this is what your diagram should look like, or if your chart should look like. You shouldn't be putting down, 2, 4, and 8, because that will make it look too complicated. And this is really easy. I just filled it out in like 10-15 seconds. So this is a great way to check your work. Let's see how many factors there are. There are a total of 4 factors. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2. So we'll be doing 4 times 3 times 3 times 2, which is 72. Because that's the total number of possible factors that you can get out of these numbers. So we can just recheck our work by making this chart. Again, in competitions, you won't be able to do this because you don't really have the time. However, when you're practicing or when you're studying by yourself, I do recommend you to create this chart, see if you actually got it right. And again, this is a great way for you to see actually how many factors, what those 72 factors are, right? So for example, you can do 2 to the second power times 5 to the first power, which is 4 times 5, right? Which is 20. 20 is a factor of 12,600. So you can actually kind of do some mix match right there. You can multiply different numbers to see what those factors actually are. It's kind of fun to do that. So you can always do this when you're actually practicing. However, again, the only thing that you really have to know from this video is to know this theorem. It's super, super important. And also know whenever you encounter these simple problems, even when you encounter these simple problems, you know how to actually approach them and actually use this basic concept to harder problems. Because in math, it's just you're adding on to the basic concept. You're not really getting anything new always. You're not actually adding on and on and on to something that you already have. You're just, using the same concept to solve the problems. So again, this was an introduction more like to positive divisors. In my next video, I'll be going to a little bit more complex concept, but it will stick to this concept. Thank you for staying on to the end of this video.
Math Genie.